Welcome to homework.
Okay, we're told some information about an unknown molecule. We know that when it was hydrogenated with hydrogen and platinum catalyst, if you need to remember what that does, a double bond with H2 over platinum will destroy the double bond and install hydrogens. Okay, and we're told that the product of hydrogenation was cyclohexane with an isopropyl at 1 and a methyl group at carbon 4. So we likely had something that looked like this, but with double bonds somewhere. We just don't know where. That's what that bit of information tells us, that this was the skeleton of our molecule, just with double bonds on it somewhere. We're also told that when the unknown was treated with ozone and dimethyl sulfide, which, if you recall, if we had R and R prime across a double bond and treated it with O3 and DMS, would give us a couple of carbonyls. It basically splits it in half and puts oxygens in the middle of the double bond. We are told that the product of ozonolysis, as it is called or known, is the following molecule. Right. So whatever, whatever we have, we know that ozonolysis led to that, and hydrogenation led to that. We also know that we got formaldehyde out from the ozonolysis. Formaldehyde looks like this. It's a hydrogen there and there. Now, that tells us that the formaldehyde tells me that at some point we had a double bond in our molecule, where this was the rest of our molecule, and there was a double bond that just had two hydrogens at the end. Right, so one possibility for that would be this, right? Uh, if that got split in half, we would get formaldehyde out. So that's very likely that we had a double bond there. So I'm just going to draw that double bond in, and let's see if that makes sense with the rest of what we got. Keep in mind that that double bond could also be here, right? Either of those would give us formaldehyde out. And in fact, once I draw this in here, I start to notice a similarity here, right? Doesn't that kind of look like if we cut that in half, put hydrogens there, that we would have gotten formaldehyde and this carbon right here. So that's very likely as well. So let's see, we're kind of just going through this with a bit of guess and check. There's no way to immediately get the answer. So let's assume that maybe that is the case, right? And then let's just go through here and trace this molecule and see where it attaches to the nearest double bond. Okay, so if we did 1, 2, 3, 4, 5 carbons through here, 1, 2, 3, 4, 5. Okay, now let's go the other way. I think you might see what I'm getting at in a second. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. Right. So it's very possible that this carbon and this carbon were once connected by a double bond. Because as we know, if they were, that carbon would be split into two. It would be split into two carbonyls, as we see here. So let's explore that idea a little more thoroughly. If we had had a double bond, make some room here. Between, say, this carbon and this carbon, and we performed ozonolysis on this molecule, we would have split this here, so we'd get O, have a methyl sticking off here. There. Something like that. And then we'd have a hydrogen here. And we can look and see if this molecule is at all possibly the same as the molecule we have over here. So let's start from our, this is supposed to be a hydrogen the whole time. Okay, so let's start from here and see if this lines up with what we do have. We've got a carbonyl, or an aldehyde right here, carbon 1, 1, 2, 3, 4, 1, 2, 3, 4, and it's got a methyl group sticking off, right? So that chain looks very similar to 1, 2, 3, 4, and 5, that chain. Now, does the other side make sense? So we go 1, 2, 3, 4, 5, and then we've got a little methyl group sticking off. 1, 2, 3. Oh, sorry, I started from the hydrogen. 1, 2, 3, 4, 5 with a methyl group sticking off. So this seems like a very good candidate for what our molecule initially was. So let's just step through that in the forward direction one more time. If we had started with cyclohexane, let's draw that a little better. Again, that we had a double bond here, had an isopropyl sticking off, and that one of those was a double bond. And we had a methyl group sticking off, and we went through H2 on platinum. We would get the same molecule, but without double bonds. Okay, and if we went through ozonolysis, we would get almost the same molecule, but now this would go to a carbon, and that carbon would look like that, and we would get our formaldehyde. So there we are. This was our unknown.